Hey everybody, welcome to our first ever episode of Miss Blue's Calc Clues. I've missed you guys a ton. So I wanted to get started on some of the questions that you guys had from 4-5 and from 4-7. So let's start with a couple of the examples you guys requested from 4-5. So let's start by looking at number 5. So number 5, they gave us 2x squared equals 7x plus 4. Now, in order to solve this quadratic by factoring, the first thing I need to do is gather all of my terms on one side so that all the terms are on one side and 0 is on the other. So I'm going to subtract 7 from each side of the equation, and I'm going to subtract 4 from each side of the equation. So I end up with 2x squared minus 7x minus 4 equals 0. And now I'm ready to factor this. I prefer using the box method, so I'll help get that all set up here. So now remember, when the leading coefficient is not 1, then we need to be looking for two numbers that add to equal our middle term, which in this case is -7, but multiply to equal a times c, which in this case would be -8, because I take 2 and my -4 and multiply them together. So I get -8. So I can put my 2x squared up here. I can put my -4 down here. And now I'm looking for two numbers that are going to add up to equal -7 and multiply to equal -8. Well, the only combination that works there is -8x and +1x. So I'll place those in those other items in the boxes. And now I'm going to solve the puzzle working backwards. So I'll put a 2x here and an x there, because 2x times x gives me my 2x squared. Over here, I'll put a -4, because -4 times 2x will give me -8x. 1 times x gives me x. And 1 times -4 gives me -4. So now what I have done here is I've been able to take this quadratic and I can rewrite it as x minus 4 times 2x plus 1 is equal to 0. Now, if we were to use the zero product property here, we have these two binomials being multiplied together, and when I multiply them by one another, the result is 0. So either x minus 4 is 0, or 2x plus 1 is 0. Add 4 to each side, x equals 4. Subtract 1 from each side and divide by 2, and x equals -1/2. So that's the solution to a problem like number 5. So let's take a second, and in that same section, let's look at something like number 6, which is very similar. So let's consider 2x squared equals -5x plus 12. The first thing I need to do is I need to gather all my terms on one side of the equation. So I'm going to add 5x to each side and subtract 12. So I end up with 2x squared plus 5x minus 12 equals 0. Now I'm in the same situation as I was last time. I need to factor. I have a leading coefficient that is not 1. And so I can fill in my 2x squared and my -12 here. I'm looking for two numbers that are going to add to equal that b term in the middle, which is 5, but multiply to equal 2 times -12, which is -24. So once I think about that combination of numbers, the combination I'm going to come up with is +8x and -3, because 8 times -3 gives us -24, but 8 plus -3 gives us 5. So now I'm ready to solve this puzzle. I'll break 2x squared down into, 2x and x. I will have a 4 here, and I will have a -3 there. So now I can take this quadratic that I had before and I can rewrite it as 2x minus 3 times x plus 4. So now using again the zero product property, I can take these two items and I know that one of the two would have to equal 0 if their product is 0. So either x equals -4 or x equals 3/2 or 1.5. So I hope that helped on problems like numbers 5 and 6. Let's take a second. Number 11 was also requested in that particular section, which is a very similar kind of idea here. So just like with the other problems, I'm going to need to isolate all of my terms to one side of the equation, and so it is set equal to 0. So I'm going to add 5x to each side and add 6 to each side. So now I am looking to factor this quadratic. I'm looking for two numbers that are going to add up to equal 5, but multiply to equal 6. That combination is going to be 2 and 3. And again, you could use the box method like we did in the last example if you find that helpful. So now I have written my quadratic as a product of two binomials. So I will use the zero product property, set them equal to 0, and find my two solutions, x equals -2 and x equals -3. So I hope that helps for the questions you all had on 4-5. So there was a request for a problem on 4-7. So let's finish up by looking at that particular problem. So the requested problem was 4-7, number 3, and it looked like this. Now again, if I wish to solve this using the quadratic formula, then I need to get all my terms onto one side and set my quadratic equal to 0. So I'm going to subtract 2 from each side. So it looks like this. Now I can identify the A, the B, and the C for this particular quadratic. And now I shall sing to you. X equals opposite B plus or minus the square root of B squared minus 4AC all over 2A. So I've applied my quadratic formula there, so I can start simplifying things. Now, bonus question, the value that goes under the square root symbol in my quadratic formula has its own special name. And the value of this quantity determines how many roots we're going to have. The term for that is called the discriminant. So I'm going to start by simplifying my discriminant first. So I have -5 plus or minus the square root of 25. 4 times 3 is 12. 12 times -2 is -24. So I'm subtracting a -24 here. All over 2 times 3, which I'll just clean that up right now, make it a good old 6. So I have 25 minus -24. That gives me 49. So I have -5 plus or minus the square root of 49 over 6. So this is the point at which I can take the square root of 49, which is 7. So my two possible solutions here are -5 plus 7 divided by 6. And my other possibility is -5 minus 7 divided by 6. So this simplifies to 2/6 or 1/3. And then this simplifies to -12/6 or -2. Anyway, I hope that cleared up some of the questions that you guys had on these particular problems and maybe gave you a push in the right direction to make some more corrections on the problems you had trouble with. Keep the questions coming. You guys are doing an amazing job of keeping up with your work, asking questions, and doing the things that you need to do to be successful. So I miss you a ton. I hope to see you all soon, and keep up the good work.